Have you ever dropped an ice cube into your drink and watched it bob to the surface? It seems so normal. We rarely stop to think about it. But why does ice float? It's not magic. It's physics. And it's one of the most wonderfully weird properties of water. Let's dive into it. You might assume that all solids are heavier than their liquid counterparts. And for most substances, you'd be right. If you were to drop a solid piece of wax into a container of melted wax, it would sink straight to the bottom. Same with iron, aluminum, and most other materials. They get denser as they get colder and solidify. So, by that logic, ice should sink in water. But it doesn't. Water is a rebel. It breaks the rules. This simple fact is one of the most important anomalies in nature, and it's the reason life on Earth can exist as we know it. So what makes water so special? It all comes down to its molecular structure. A water molecule, H2O, is made of one oxygen atom and two hydrogen atoms. These atoms are bonded in a way that creates a slight electrical charge, making water a polar molecule. Think of it like a tiny magnet with a positive end and a negative end. In its liquid state, these water molecules are constantly moving, tumbling over each other and forming temporary bonds. They're pretty tightly packed together, like people in a bustling crowd. But when the temperature drops and water begins to freeze, something fascinating happens. As the water molecules slow down, they stop tumbling around and start to arrange themselves into a highly ordered repeating pattern. This pattern is called a crystal lattice. Specifically, they form a hexagonal crystalline structure. The hydrogen bonds, those connections between the positive and negative ends of the water molecules, lock them into place. But here is the crucial part. This crystal structure is as compact as the jumbled molecules in liquid water. The molecules in ice are held at a fixed distance from each other, creating more empty space within the structure. Imagine that bustling crowd suddenly organizing into neat rows, with everyone holding their arms out. They would take up much more space. This increase in space or volume is the key. Density is simply mass divided by volume. Since the mass of the water hasn't changed, we still have the same number of molecules, but the volume has increased, the overall density must decrease. In fact, ice is about 9% less dense than liquid water. And that's the answer to our original question. Anything less dense than the fluid it's in will float. It's the principle of buoyancy. The ice cube floats because it's lighter than the volume of water it displaces. It pushes aside an amount of water that weighs more than the ice cube itself, so the water pushes back with enough force to hold it up. So ice cubes rise to the surface of your glass, and massive icebergs float in the ocean for the exact same reason. They are less dense than the liquid water surrounding them. They rise to the top, displacing the heavier liquid water below. This seemingly simple property has profound consequences for our entire planet. Think about what would happen if ice were denser than water. During winter, as the surface of a lake or ocean cooled, the ice would form and sink to the bottom. Then more water would be exposed, freeze, and sink. Over time, entire lakes, rivers, and even oceans would freeze solid from the bottom up, wiping out almost all aquatic life. Instead, because ice floats, it forms an insulating layer on the surface of the water. This layer of ice protects the liquid water underneath from the cold air above, keeping it from freezing. It creates a stable liquid environment where fish and other aquatic organisms can survive the winter. This is absolutely critical for the biodiversity of our planet's aquatic ecosystems. The floating ice acts like a cozy blanket, preserving the liquid world below. It's a natural survival mechanism that has allowed life to thrive in even the coldest regions of the Earth. The impact doesn't stop there. This property is also why massive glaciers and ice sheets can float. When a piece of a glacier breaks off, it becomes an iceberg that drifts across the ocean, carried by currents. These icebergs play a role in transporting fresh water and minerals across vast distances, influencing ocean circulation and marine ecosystems. The floating polar ice caps also reflect sunlight back into space, a phenomenon known as the albedo effect, which helps regulate the Earth's temperature. So, The fact that ice floats is a fundamental driver of global climate patterns. Scientists refer to this unique behavior of water as its density anomaly. While a few other substances exhibit similar properties, it's extremely rare. For a substance as common and vital as water, this anomaly is truly exceptional. It's what makes water the perfect medium for life. It moderates climates, creates stable habitats, and enables the complex chemistry that life depends on. From the drink on your table to the vast polar ice caps, this simple principle is at play everywhere. So the next time you drop an ice cube into your drink and see it float, you'll know you re-witnessing one of nature's most important and elegant rules being broken. Ice floats because freezing water expands, making it less dense than the liquid around it. It's a simple act with world-shaping consequences. It's a beautiful reminder that sometimes breaking the rules is exactly what's needed to make life possible. What other everyday mysteries do you think we should investigate next? Let us know in the comments below. Thanks for watching, and don't forget to like and subscribe for more deep dives into the world around us.